Okay, here I'm going to work through how um, the card deck could have been completed. Again, I'd kind of given you the beginnings of it, and with the beginnings, what there was a possibility of actually testing out. So I encourage writing a little bit of code and then testing it out. So start by instantiating a card deck and just print it out. And see what happens. Okay, notice when I when I did this, NetBeans actually added the import for me. If it doesn't and you get the red squiggly again, the go-to thing to do as a start is to right-click and select Print Fix Imports. All right, so let's try running this and see what it does. And you can see it just got the gobbledygook there. Okay, so if you're getting this, that means you have not written a toString. So actually, let's do that. Just so we can see what we got. Okay, so the suggested way of doing this is begin with an empty string and then loop over. In fact, we can use a for each on this. So for single card in my cards, we can simply concatenate the card and concatenate a new line as was suggested, and then finally return the output. Again, what you call it is not important. Again, I always like to have this little override thing. Again, it's not required, but it's always very useful. Okay, so the reason it's useful to write the toString first is we can now see what's going on here. So now when I run, well, look what I'm getting. I'm getting 52 nulls. Well, I assume 52 nulls. I haven't counted them. Okay, so what does that mean? That means that my cards array in CardDeck has not been initialized. And why? Well, because create new deck has not initialized it. Okay, so now here, this was what we want to do is we want to take the code that we had done for the single card and you just kind of plop it in. Okay, so and the order doesn't really matter. The traditional order is clubs, diamonds, hearts, and spades. Again, that's not required. But again, okay, now what did we do? We basically were over here. We were using the same. Again, this was in the previous assignment. So we just want to kind of do this something very similar. So we want our index. We start with an index. And we loop over the suits length, and then we loop over the values. And again, I think you all got this this thing okay. See, there's no. Oops. Yeah, sorry. Oh, let's just do it the regular way. And my cards of index is equal to new single card of, and what does it need? It needs a suit. So and what's the current suit? The current suit is suits I, and the current value is j plus 1. Again, here's this off by one thing. Okay, that's all we need. And having written just this little bit of code, I want to test it again. See, remember the first time I tested it, I got nothing but nulls. Now when I run it, I get the king of spades and nothing more. Okay, so what happened? What happened was I did not increment the index. Okay, you see that? So what did it do? It buzzed down everything from the ace of clubs all the way up to the king of spades, and then but it dropped them all into the 0-1. So now when so now I'm getting what I want. Ace of clubs all the way through the very end. Okay, now notice that CardDeck has doesn't know anything about any of this stuff. All of this is done in the single card. Okay, so that's progress of sorts. And now I need to, let's see what else needs to be done. So here's the assignment. And here's the UML diagram for CardDeck. Okay, so we already defined single card and the generator. We got create new deck. Shuffle deck is kind of the next one there. So let's implement that. Now the thing about this, what we need to do here is loop over our my cards array. And again, when you're looping over an array, if I'm looping over the whole thing, I can use the for each business here if I don't care about the index. Here I can't do that because I care about the index. In other words, the index is a critical one. So in other words, the random index is generator next int, and my upper bound is the length of my cards. Okay, so this will generate a random index between 0 and the length of my cards minus 1. So if you read the documentation carefully, and okay, now how do you do this? I can click on this, and if I hit Control Space, it brings up the Java doc for that. We're going to talk next week about what Java doc is, and we see that next int produces a pseudorandom uniformly distributed int value between 0 inclusive and the specified value exclusive. Okay, what that means is it's going, see, the length of my cards is 52. This will create a pseudo-random integer between 0 and 51. That's what the exclusive means. Okay, so now and there are several ways to do this, but okay, so what I'll do is I'll take that random index, I'll put that in temp, and now my cards at random index, I'm going to set to my cards at I, which is this one. And then finally, my cards at I is going to be the temp. Okay, so let's test that out. How do we test that out? Well, here it's. Okay. Before the shuffle. And then now after the shuffle. Got fat fingers tonight. So what I want to do is I want to do CardDeck, shuffle, and then just print it out again. Okay, now when I run it, I get before the shuffle everything is the same. And then after the shuffle, I see that they're all mixed up now. Okay, so that's in terms of the output, that was kind of the test there. Now, in terms of getting them, let's look at what the requirements are. So there's a getter for my cards, and the way to do that is I can select this, choose refactor, encapsulate fields, no setter. I want to have just the getter, and let's put it after shuffle deck but before toString. The field's visibility private, the accessor is public. Okay. Now here's where there were a number of places that lost some points. And that is, this returns my cards itself, and that's the encapsulation breach that I talked about. So this needs to be cloned. That is absolutely necessary. Let me show you what happens if I don't do that. Okay, so let's come back to our test. Okay, after all this, let's create a new deck. And let's just get it. So we have CardDeck, get my cards. Okay, now again, this is not cloned. And so again, red squiggly, what do you do here? If it says cannot find symbol, I try to find it with imports. Again, that does not work all the time. It works most of the time. All right, so okay, so that's kind of, I have this array, but now that I got this array, I can do stuff to it. So let's make the 51st one the let's make it the 10. Oops. What does it want? It wants the suit first. Okay, so let's make it the pentacles, the 10 of pentacles. All right. Now, okay, so again, watch what happened. Okay, so everything was fine up until I simply got, I invoked a method, I got a return value, and I took that return value and I did something to it. I just simply set the 51st value to something that's new. And then now look at what happened. My king of spades is now the 10 of pentacles. That's not very good. Okay, that's why encapsulation is such an important thing to maintain, and which is why with arrays you'd never want to return the array itself. You want to return a clone of the array. Now when I do it, okay, so even though I've, see what's happened is because I got a copy, this just mucked up my copy, and that's on me. But I have not altered what's inside the object. Okay, and the final piece, and again, this was not really tested completely, or I mean, I didn't explicitly ask you to test it. And the idea here is to simply return the index of the card. I'm saying I want the card at this index and you're going to give it to me. Now this does not break encapsulation because the single card is immutable. Once I have a single card, I can't do anything to it. I can't change its value. I can't change its suit. Okay, so how do I test this? Let's get card. Oh, let's see what's at the 25th index. And how would I? Okay, so I'm getting the one at 25. So the single card at index 25 is the king of diamonds. Okay, so hopefully that's correct. For an unshuffled deck, that should be the correct one. In fact, I can compare it with the 25th one that I get here. And again, it indeed is the king of diamonds. Now, the one thing, of course, you got to be a little careful of is, and we haven't had a chance to really talk about this too much, is that what would happen if I tried to get an index that was not legitimate? See, it lets me get it, but this is going to produce something called an array index out of bounds exception. Okay, so in fact, the following Java return. Okay, so what happened? The error was kind of mixed up in here. Here we go. Array index out of bounds exception. Index 52 is out of bounds for length 52. And at face value, that's such a silly error. Because index 52 is out of bounds for length 52. All right, why? Because of the off by 1. The last index is index 51, and not 52. So let's just leave that out. And just make a note. Okay, so yeah, that's a little bit of a, I would say like just a little wart on this. There is a way to deal with this, and it involves throwing exceptions rather than relying on what Java's making us do. What we want to do is we want to say, all right, if if this index that we give it is not between 0 and the length of my cards, then it's just not going to work. Okay, but that is for a later date. In the meantime, we want to comment it. And again, next week we are going to go through what these Java docs are about. And then, in fact, there's like a little okay, so if index is less than 0 or greater than 51. Might be confused about this. The format of this Java doc is HTML5, and so we can't use the greater than and less than because HTML gets confused by that. Okay, so again, just to recap, what have we done? We have finished creating the card deck according to the specifications. Now, one way that this could be improved is actually right here. Notice every time we call create new deck, it instantiates another array of suits. And that's actually an indication that it would be, this is something that can be made a static variable. Not going to deal with that right now, but that's going to be subject for a future piece of information. Okay, so that's, and then just to bring this to completion, let's commit it. So okay, so we finished that. I commit that. And I wait till everything turns black. Then, now here's, it's always a good idea to pull first before pushing. In this case, it doesn't do anything. You can actually kind of see what it's done is, is over here. It kind of see where it says pulling, and it said no update. So I'm all up to date on that. But I'm not. I'm actually ahead. So what I need to do here is to now push it. In other words, see again, master U. Okay, so now if you pull this down, you'll have at least a working CardDeck class that can be used for the next assignment.